Thank you. Again, today, some of the things I want to say, I think, need to be said in just the right way. So I'll read the bulk of what I'm going to say today. Yesterday, I talked a lot about RCTs. Now, RCTs establish causal laws, and that's what everyone agrees. Now, if you've ever participated in constructing or evaluating an RCT, or even just seriously thought about social science method and biomedical science method, you know that RCTs are hard to get right. And it's no easier to establish causal laws with other methods. It's not any easier to get it right with other methods. So knowledge of causal laws is hard to come by, and it's expensive. Yet we make enormous efforts to obtain it. So what's the use of knowing causal laws? I always suppose that knowing causal laws helps us to change the world, in a very immediate way. We can read off from the causal laws ways to manipulate the world to achieve the effects described in the laws. Nor have I been alone in this supposition. It is, I think, at the heart of the now very trendy manipulation theories of causality. Okay, but this assumption is mistaken. And that's been devastating for me because I started this enterprise at the beginning of my career when you weren't allowed to talk about causality, and I began to do so because I thought that causes were effective strategies. So I've been devastated to recognize that they're not. Okay. Knowledge of causal laws cannot play this special role, and today I will explain why. But first, I have to give a very, very, very lengthy explanation of what causal laws are, okay? Because we're philosophers, and we do really want to know if we're going to evaluate this. Okay, so I will also then provide one special case where causal knowledge can be used in the way envisaged, and that's the case where we know about capacities. You can also use it in the way we envisage when nomological machines are at work, and that's what I'll talk about next time. Okay, now causal laws, as I see it, have a number of specific features. Okay, the first is they are population situation relative. They describe relations that hold among quantities in a particular kind of population and particular kinds of circumstances, though this relativization is often left to context, to supply. The second is the primacy of singular causation. The causal relation, and this is my reading on them. Some of the things I think it would be odd for there not to be universal agreement about. Some of the things are my way of making sense of it, and some of the things that are just my way of making sense of. If you can make sense of them in some other way that still gets the things that I feel we have to agree on in, I don't really mind, okay? But I think that really we should take singular causation as primary. The causal relation reported in so this gives us something, the understanding of what causal laws really say. The causal relation they report is not primitive. It's not an abstract relation between universals, for instance. Rather, causal laws describe what singular causal processes will or can occur in the specified circumstances. And then, in keeping with the fact that a causal law reports what singular causal processes will or can occur, a causal law picks out at least one complete set of causes. The specified set is enough to produce the effect, and nothing more need to be added. And that's the work that's done by the equality sign. Remember, I've written down a paradigm causal expression for a causal law, CP, the causal principle, and it has an equality sign in it, and that the right-hand side is enough for the left-hand side is what you see in the equality sign. That it's causal is what you see in that little C that comes in front of the equality sign. Now, the laws may be either deterministic or probabilistic, okay? And there are factual effects. So causal laws specify what effects will obtain when the specified causes obtain. They do not describe counterfactual effects that would or could obtain were the causes different from what's specified on the right-hand side. Now, this may sound odd to stress, but it's something that various, well, Jim Woodward's manipulation theory doesn't agree with. Okay. Nor do they presuppose that the specified causes are produced in any special way. It's just if it tells you that when you've got the causes on the right-hand side taking their values, that causes the effects on the left-hand side. So they don't presuppose that the specified causes are produced in any special way unless that is stated in the description of the situation to which the law is relativized. Because after all, they're all populations and situation relative. So consider CP, right, the one we've been looking at. And imagine that CP works in S. So CP says that in every individual unit, U in S, whenever alpha of U takes the value A, beta of U takes the value B, X of U takes the value little x, and W of U takes the value W, this causes Y of U to take the value, oopsie, sorry, this causes Y of U to take the value A plus BX plus W. I think that's fairly straightforward. Okay. Now, this account of causal laws has a number of virtues. So let's look at the virtues. First, it tells us what causal laws say, which is something hardly anybody else does. Okay. A lot of people give some criteria that causal laws should satisfy, but they don't actually tell you what causal laws say. Okay. Now, it tells us what causal laws say. Many contemporary treatments of causality in philosophy of science do not do so, including common versions of the probabilistic theory of causality, related Bayes-Netz theories, and some versions of manipulation and invariance under manipulation accounts. Consider the probabilistic theory of causality, and let's just look at yes-no variables, which is the way it's often treated. Okay. One fairly good attempt at formulating a probabilistic theory of causality says this: C causes E in a test population K for situation S, if and only if in S the probability of in S holding K fixed, C raises the probability of E. Okay. So what's K? Okay. A test population, K represents any test population, and a test population is any population or any situation in which all the other sources of variation in the probability of E are held fixed barring C and its downstream effects. Okay. Okay, so if you manage to hold fixed all the other causes of variation in E, when C changes, the probability of E changes, then C must be responsible for that, and we think the only way C could be responsible for that is that there are singular causal processes going on in which C's are causing E's. Okay. Now, if you take this as relativized to test populations, it's relativized not only to situations but to test populations. Okay. If you want to, my view is, I would say C causes E in S simpliciter if it does so in any test population in S. Okay. There are various ways you could do it. I mean, you could say that if there's some test population in S that this is satisfied, it causes E, or it has to do it in every one, and those are just variations on how one uses the term causal law. The way I use it, that if C causes E in S, if it doesn't any subpopulation, in any test subpopulation, has the effect that it can be both true that C causes E in S and C causes not E in S, because in one test situation it could cause it and another not. If you don't like that, you could ask that it do so in all, and there have been many variations on that. We're not really doing probabilistic theory of causality today. Okay, so what's important here is that there are at least two understandings of this theory. Okay. Sorry, what's important is that the first one explains, on the one hand, we can see it as an answer to my question about what a causal law says. the law C causes E in S on this probabilistic theory, not my theory about singular causation, but on the probabilistic theory of causation, C causes E in S, says that the probability of E given C and K is greater than the probability of E given not C and K for some test population K, which is a subset of S. Okay. On the other hand, we can see the probabilistic theory of causality as providing a sufficient condition for the truth of a claim that says something else more immediately about causation. And that's what I try to do when I talk about singular causing, singular causal processes. I offer an account of what the law says in terms of singular causings that will occur in the long run, because we're doing probabilities. Then I show for various kinds of causal systems that when the probabilistic theory is formulated appropriately for them, the increase in conditional probability is indeed sufficient for the related causal laws to be true, where I mean the causal laws that say this, that certain singular causal happenings will happen, I mean, ones that start with C and end with E, and actually tell you what the probability of that is. Now, these two understandings of the probabilistic theory can also help make clearer my concern that we should, if we can, offer an account of what causal laws say. Many discussions nowadays settle for describing some central characterizing features of causal laws. That's been the game in philosophy of science for about over a decade and a half now. Often these descriptions themselves refer to causal laws, as in the probabilistic theory, right? Because here in the probabilistic theory we're told that C causes E just in case it increases the probability in a test population, and to tell you what a test population is, I have to refer to the other causes, which means the other things that occur in the antecedents of causal laws. So if you thought of it as a definition of causation, it would be circular. I mean, it really does define causal laws using the notion of causal laws. That doesn't mean that it's not an interesting characterizing feature that restricts the notion of causal law dramatically. So often in these descriptions refer to causal laws. In this case, the descriptions cannot serve as proper definitions. That's not the concern I'm raising, however. What I want to know is what a causal law says, and what it says could very well include something about other causal laws. Okay. Now, the account I offer of causal laws is empiricist. I'm continuing the virtues. The account I offer of causal laws is empiricist in what I take to be the most important sense. That's stressed by Otto Neurath. Sorry, I suddenly realized I don't have a picture of Otto Neurath, and since he's my hero, and I've got pictures of everyone else, and you'll see, I don't know why he's not there. Okay, well, the account I offer of causal laws is empiricist in the sense stressed by Otto Neurath. It is this worldly. Causal laws do not describe relations between universals, nor structures behind the happenings. They describe what happens in this world when the causes are instantiated here. This account of what causal laws say also dovetails with a panoply of our most favored methods for testing causal laws. Not just RCTs, but also various statistical methods used in econometrics and other social sciences, the Mark method, controlled experiments, and tests looking for invariance under controlled interventions. I take this to be a strong argument in favor of this interpretation of what causal laws say, since it is essential to good philosophy and to good scientific practice that metaphysics and methodology march hand in hand. So when I tell you what causal laws say, that should march hand in hand with seeing why the methods we use to find out about them are methods to find out about just what I've said they say, and vice versa. So metaphysics and methods should march hand in hand, or there's something wrong on one side or the other. Okay, so either the scientists or the philosophers aren't doing their job right. Now, my worry is that, contrary to expectation, causal laws cannot provide the kind of information we need to predict what will happen as we attempt to change the world. For this reason, an account of causal laws that meshes with methodology matters, since we seem to assume that what we establish with our best methods for testing causal laws is knowledge that we can use directly in this way, to change the world for strategies. And much of what okay, so I often now, I think in the last few months have been talking about strategy by pun. So you establish something you call a causal connection, and then you believe that if you've got some word like cause in a premise, you can draw some inferences about strategies, right? But you never make sure that the very thing that your method will entitle you to assume is the very thing that your inference requires in order to be a good inference. So just because it's got the same words like causes in it, we're just making the bridge by pun. And that's a bad idea. Okay. And a rich metaphysics will, it's a rich metaphysics that usually allows you, that makes for the bridge. And most of the metaphysics that's built into our doctrines about causality won't do it. Okay. So let me turn to what I'm going to add-on accounts versus intrinsic accounts of causal laws. So there, it's not just me. This kind of worry about causal laws is something that a lot of people have cottoned on to from different directions, and there are fixes for it. Not everybody, oh goodness, I'm sorry, I need to go back a minute. Virtues, before we leave virtues, because I realize I've, back on the characterizing features. I realize I left out an important one. So we had that list of what about causal laws, and one of the ones the really important one I've left out is that causal laws are in most of, I think in the domains where it's appropriate to use the terminology, causal laws are responsible for any regularities that are obtained other than by just happenstance of finite frequency accident. And that's whether they're probabilistic regularities or universal Humean regularities. Either they are themselves just enactments of the causal laws, or they're due to the operation of causal laws. And this is a really important fact about methodology, because a whole lot of our statistical methodology, right, it looks at regularities, it looks at correlations, and then you reason backwards from correlations. You don't take correlation to be immediate mark of causality, but basically once there's a correlation, a real correlation and a probabilistic dependence between two variables, we look for a causal story that lies behind it. And you see this, for instance, in Bayes-Netz's methods, where it's just assumed that if there's a cause-effect relationship, there's a probabilistic dependence between them. And if there's a probabilistic dependence, if they're not themselves cause-effect of each other, then there's some causal story to be told, like they have a joint cause in common. So it's an important feature of causal laws that they're responsible for and you can derive from them, a full set of them, any of the regularities that hold by law. Okay. Now, let's go on to fixes on the problem that causal laws do not provide effective strategies. Economists, at least from the time of J.S. Mill, have worried about the usefulness of causal laws for policy prediction due to their instability. Okay, there's J.S. Mill. Mill worried about naturally occurring variations in both background arrangement of causes and in the underpinning structures that support causal laws. Okay. Early econometricians and more recently Chicago School economists like, Robert Lucas, worry about the likelihood that active policy intervention can undermine the structural arrangements that support the causal laws. So Lucas's picture is that there, and you'll see this again tomorrow, that there's that what's really going on in the economy is agents, rational agents interacting on their preferences in the face of technology, given technology and changing technology and what he calls exogenous shocks. That's what's really going on in the economy that gives rise to a lot of macroeconomic regularities, which are genuinely causal laws. It really is the case that the antecedent, like the Phillips curve, that rising in, for a while it really was true that rising inflation causes lowering unemployment levels. But as soon as the government, says Lucas, as soon as the government tries to use this causal law to improve unemployment, they break the underlying structure that makes the causal law hold in the first place. So this is the kind of worry that economists have, that the causal laws that these underlying structures give rise to are genuine causal laws, but we can't use them. Right? They're okay. So now, the worries I raise here about the usefulness of causal laws for policy predictions echo worries about the stability of causal laws by economists. To explain my worry, I shall review a few further recent accounts of causality that aim to provide central characterizing features of causal laws, focusing on accounts that treat economic causes, since it's these accounts that are most alert to the problems of fragility of causal laws that worry me. Okay? Begin with the probabilistic theory of causation, which provides a provably sufficient condition for the designated cause to appear in a true causal law. I mean, that was what for a given population S, focus on some particular test subpopulation K, so we can repress K in the... Sorry, let me back up, and I will repeat what I said. The probabilistic theory of causation provides a provably sufficient condition for the cause to appear in a true causal law for the effect, where causal laws are understood in the way I described. Okay, so I can do a little representation theorem. You'll notice I do a handful of representation theorems to show that. Now, I'm not going to show that, but I want to show why you might think that if you believed in the probabilistic theory of causality either as a sufficient condition, as I say, or you actually believe that that's sort of how what causal laws say. I mean, that's what a causal law is just something, a shorthand way of telling you that the probabilities increase in the right places. Okay, it looks as if the fact of this probability increase is really good for our ability to use causal laws. But it's not, and that's what I want to show you, is don't be misled. You might not, you didn't even get so far, maybe people who haven't done this before to have gotten misled. But so let's look at this. For a given population, for a given population S, okay, we're going to focus on a particular test subpopulation K, so I can repress K and we don't have so many symbols in the equations. Okay. Now consider what use we can make of this knowledge of this causal law, that C causes E in K. What use can we make of that for policy predictions about the effects in K? Okay. Let's see. Well, let's back up. So what use can we make of this about the effects in K on E of changing C? That's what we think we're going to do. Right? C causes E in K. We'd like to get more E or less E, so let's change C. That sounds like a great policy. And the probabilistic account of causality seems ideal for providing an answer. So here we are. Increase the probability of C, and the probability of E will increase, because you can just, this simple formula here is, this is true simply by definition of the conditional probability. So if you increase the probability of C, the probability of E should go up. Okay. That looks good. Okay, so if the probability of C increases, so should the probability of E, supposing that the probability of E given C is bigger than the probability of E without C, which is what the probabilistic theory of causality demands. Does everybody see why you might, you're happy with that? No? Yes? Okay. Now, That's the idea, but it's just not true. Okay. The formula is for this formula up here is for a given probability measure P. Okay. The probability of C, P of C, cannot change, right, without P itself changing. And if P changes to some new probability, P prime, okay, the fact that the probability of E given C is greater than or not C under the old measure P determines nothing about the relationship between P prime of E given C and P prime of E given not C. Okay? So knowing that C causes E and K, and hence that the conditional probability there under where P holds does not help us predict the effects on E of manipulating C in K, because that means that as soon as you start manipulating C, you've changed from the old probability measure in which that was assured that the one probability is higher than the other, but as soon as you actually change the probability of C, you've destroyed that probability measure. You've moved to a new one, and God knows what happens. Right? Okay. Now, this is exactly the problem that one of my heroes, econometrician David Hendry, is concerned about. As with the probabilistic theory of causality, Hendry focuses on the conditional probability of the effect on the hypothesized cause, P of E given C. His primary attention is to cases where C is what he calls strictly exogenous to E. I'm only going to tell you what that means so you don't get fussed. You don't have to know what exogenous means. It's the add-on that he makes that matters. But it has to do with statistical estimation. It means that the conditional probability, the one we're interested in, P of E given C, can be estimated without attention to the marginal probability of P of C. So, now, but for the relationship between C and E to be causal, however, Henry requires what he calls super exogeneity. Okay? P of E given C must be constant across the envisaged changes. So if it were constant, of course, the conclusion we wanted in the first place would hold. So what he does is he just says, he doesn't accept the probabilistic theory of causality, which doesn't have this built in. He just says, look, I'm not going to call it causal. Sorry. I'm not going to call it causal unless something else is true. You've got a stability of the fact that it is causal. I mean, that's all. Requiring that P of E given C be stable across the changes, that just is, you know, if it was, so that if it was bigger than E given not C before, it'll be bigger than E given not C after. That's just another way of saying, if you hold the probabilistic theory, that it just is stable. We're not going to call the causal law stable, call something a causal law that satisfies the probabilistic theory for being a causal law here. We're not going to call it a causal law unless it happens it's also a causal law here. So that's why I call it an add-on account. Okay. P of E given C must be invariant across, but for him it's across the envisaged policy changes. C causes E does not count as a causal law unless the conditional probability remains fixed across the manipulations envisaged to change C. So this is an example of what I call an add-on account of causality par excellence. A criterion that's sufficient to guarantee a causal law on its own. Remember, I said the probabilistic theory of causality is provably sufficient for being a causal law in the sense that I outlined. Okay? So a criterion that is sufficient to guarantee a causal law on its own is provided, as I indicated, the probabilistic theory with its emphasis on P of E given C is provably sufficient for a causal law to obtain. So you start out with a criterion that's sufficient, and then invariance is added on as a second demand before the label causal is allowed. Okay. One can, of course, quarrel with my account of what a causal law says, insisting that the account is not complete until invariance is added on. Okay. But recall the demand for a connection between the content of a causal law and our best methods for testing causal laws. the additional invariance requirement is not part of our standard methods, from the Mark method through Bayes-Netz methods to RCTs. Okay. Now, James Woodward also has an add-on account. For Woodward, okay, two demands must be fulfilled for equations like CP to be labeled causal. The first he calls level invariance. The equation must remain invariant under changes on the right-hand side variables by intervention. So you've got a causal law, effect on the left, causes on the right. If you, by a kind of David Lewis kind of miracle, you change one of those causes, don't change anything else, just at the last second you change one of the causes on the right-hand side, then the equation should remain true. That is, E should take the new value, right, that's dictated by the new value of C. That's level invariance. That's a really good test for causation. Okay. Intervention, as I said, is something like a miracle from the Lewis account of counterfactuals, a change that affects nothing other than the causes and its downstream effects. Woodward defends this account, this condition on causality, with examples in which it is violated by relations known to be spurious. So how does he defend that this is a necessary and sufficient condition? In level invariances, well, he doesn't say it's necessary and sufficient, I do. But how does he defend it as a condition? Right? He looks at cases where well-known counterexamples to the things that aren't causal laws and shows it fails. That doesn't actually show that it's a condition on causality. What we want to know is whether all spurious relations violate it. Okay? Is level invariance a sufficient condition for causality? Okay? And I prove a representation theorem, get another representation theorem, more complicated this one, that shows that it is. I begin with some axioms that a set of causal laws should satisfy, and that they do satisfy on my reading of them, like asymmetry, irreflexivity, and then the thing that I neglected to put in my list, that any functional relations that hold are generated by genuine causal laws. The theorem shows that any functional relation generated by a set of causal laws will be one of those causal laws if and only if it's level invariant. So something is a causal law, okay, if and only if it satisfies level invariance under these handful of axioms for causal laws. Okay. I don't go all the way back. I mean, those axioms are satisfied by what I say a causal law says, but you don't have to go all the way back to my reading if you're happy with the axioms. So if you've got another reading, as long as you assume asymmetry or reflexivity and the assumption that any functional relations hold are generated by causal laws, I can prove that level invariance is a sure marker that an equation represents a causal law. But Woodward doesn't think so. Okay? He demands more. Okay? Okay. He demands what he calls modularity. And modularity says that there must be some way to change each variable in a causal law without changing anything else except downstream effects. So essentially, what we show is that, what I can show is level invariance is that if you were to change it, the E would change in the, if you were to change it by a miracle, if you were to change any of the causes by a miracle, the effect would change in the right way. What Woodward requires in addition is, and moreover, you can change every single one of those causes in the right way. Okay. Now why? Well, Woodward is clear. This addition allows us to, you can change it in the right way, and since the thing is level invariant, it stays the same. Now, why? Woodward is clear. This addition allows us to use the law for manipulation. Okay? That is, I mean, he tells you now you can change every one of these by miracle. So if you've got a miracle to hand, you can manipulate any of the causes to produce the predicted effect. Okay? Now, that's why I take it Woodward calls his account indifferently an invariance account and a manipulability account. Now, as an answer to my worries, I think that this is, and it's an add-on account, right? I mean, level invariance is sufficient for a causal law, but you won't call it a causal law unless you can actually manipulate it without breaking it. Okay. Now, as an answer to my worries, Woodward's add-on is far less satisfactory than Henry's condition, for it underwrites the use of causal laws for predicting outcomes, not for manipulations we envisage making, as with Henry, but interventions which are very special kinds of surgical incisions. Okay. Note, though, that so the only time you could ever use, you're ever guaranteed you could use one of these laws is if you've got this really, really special way of doing it. That's kind of David Lewis' last-second miracle intervention to change the cause, which is not the way we ever do it. Okay. Now, you should note, though, that these kinds of surgical incisions, these miracle interventions, are the kinds, essentially, that are demanded in an RCT. So what Woodward is really getting from his modularity condition isn't actually genuine usefulness, usability of the law, doesn't provide us with strategies, but what it does ensure is that the law is testable, because you can actually change every one of the causes and see whether or not the effect changes. Okay, so he just confuses, I think, usability and testability. Now, even if modularity did ensure usability, it goes no way to showing that causal laws are useful in themselves. Level invariance already provides a sufficient condition for an equation to represent a causal law. Modularity, like super exogeneity, is an add-on. Now, to reinforce this, turn to an account of causality offered by macroeconomist and methodologist Kevin Hoover. Okay. Now, Kevin Hoover, I like Kevin Hoover because manipulation theories are all the rage, and Kevin Hoover is the only person who's got a real manipulation theory, I think. Okay. So Kevin Hoover, and he has an account that is not an add-on account. Hoover defines causality directly in terms of the effects that can be achieved by manipulation. So this is Hoover. C causes E if and only if anything we can do to fix C partially fixes E, but not the reverse. Now that's a manipulation theory of causality. Now, although this definition secures a connection between causation and manipulation, and it does so with no add-ons, the kind of relations it calls causal would not count as causal in everybody's books. And here's a simple example. So just assume that the black arrows, I've actually given my book on causation a little machine, right? That of which has real description as real machine components, where the black arrows are mechanical causation. You push that and the next thing moves. So the black arrows are mechanical causation. Okay. And we can manipulate ux and uz. Now, given that, and that's all we can manipulate, given that anything we can do to fix y fixes z and not the reverse. So y Hoover causes z, which doesn't bother me because I can manipulate y to manipulate z. I mean, it happens inside the machine. X is getting manipulated as well, but it gives you the right outcomes about what you can do with manipulation, but it's not what everyone would call causation. Now, I don't mind because I'm a causal pluralist, even though I've told you the story about causal laws and what they say. That's only actually one of the various accounts of causality I would countenance with different ones for different purposes. But it's one I would do with causal laws. Okay, so anyway, here we are. Okay. Now, the dotted lines are Hoover causes. Now, Hoover does not need add-ons. Hoover causal laws, by their very nature, provide predictions about strategies for manipulating the world. But many will not want to allow that Hoover's is an account of causation at all. Okay, so this is just to contrast an add-on account with one that really just goes for it directly. So what's wrong with adding on invariance assumptions? Well, we could add it on as an additional requirement for the use of causal laws. Okay, so one thing is these guys Woodward and Henry, they want to add it on before they'll call something a causal law, something that I think we have every good reason to call a causal law in the first place. They won't call unless they have add-on invariance. I'd be happy if you added it on not to what you meant by being a causal law, but if you added it on as a requirement for the use of causal laws. Something like this. Warning, do not use this product for predictions, for predicting the consequences of manipulations without ensuring that it is invariant under those manipulations. Okay. But I think it would be a bad idea to add it on as a requirement on the truth of causal laws, and that's for a number of reasons. Okay. As I stressed, this would break the connection between the metaphysics of causal laws and our standard methods for testing them. Of course, we could throw out our standard methods for testing them, but then we'd have to have something call something else the stuff that our standard methods test. Okay. It relativizes the concept to the manipulation under which it is supposed to be invariant, okay, the add-on account. It breaks with standard usage of the concept of causal law that we put to other purposes. We want to know about what I call causal laws for systems that are shaky, where attempts to manipulate the causes may undermine the laws. Snowflakes and spider webs, undiffusible bombs, and old-fashioned children's toys that break if wound up too tightly. And also for systems that we never intend to manipulate, nor never could manipulate, like the processes in the sun that produce light and heat, the planetary system, and the innards of my car engine and computer, where I firmly intend never to go. Okay. Now, once we allow, another reason is once we allow invariance to be added on, causal knowledge seems to have no special role at all. Remember, we're doing all this expensive stuff to get causal knowledge, and if you don't call something causal unless you've got invariance, it turns out that causal knowledge has no special role, okay? Because any claim that's invariant under a proposed manipulation of some factor will provide correct predictions about the results of manipulating that factor. Okay, so if you've got invariance, you don't need causality. Look again at CP, and suppose it is functionally correct, but is not a causal law. So take away the little c over there, so this is going to be something that's functionally correct. It's not a causal law, it's a spurious correlation. Okay. If we insist that the functional relation be invariant under a particular manipulation before we call it a causal law, okay, but let's not think about causal laws, let's just think about invariance itself. If you're going to insist that a relation be invariant, okay, let's insist that this relation that's not a causal law, I should have taken the C out, this relation that's not a causal law is invariant. Okay. If we insist on invariance of the relation, okay, then imagine that it's supposed to be invariant under a particular manipulation, say of W. Okay. Now, whether the equation expresses a causal law is irrelevant to what we can predict about Y. I mean, if I say this stays true as I vary W, well, it stays true as I vary W, and I can use it to predict what happens to Y as I vary W. It's trivial. Okay. So if we insist on invariance of the relation, any relation is as good as a causal relation for predictions about results of the manipulation. And if we do not insist on invariance of the relation, causal relations have no guarantee to do the job. Now, none of this would be so critical if causal laws tended to be invariant, if they were always invariant or almost always invariant as a matter of empirical fact. But they do not. That follows from my observations. Causal laws are both fragile, they break readily when we try to use them, and they are local. Very different causal laws hold in different circumstances. Okay. I think we can do far better if we focus instead not on the frequency with which causal laws are stable, but rather on what kinds of situations make for stability and whether we can recognize them. Okay. So I'm going to give up altogether on the idea that causal laws, as causal laws, are invariant. They're most useful to us when they're invariant, so when are they invariant? Right? And not just say, oh, most of the time, or enough of the time, or I'll just bet on it this time. Right? I think there are actually cases where we know that they're invariant. And so I start with capacities, and I'm not going to tell you much about them, but I mean, that's the job for today, is to finish with talking about capacities. Capacities, unlike causal laws, are what I call capacities. Other people call causal powers, and I use the word capacity when causal powers were really, really, really out of fashion a long time ago. And there was so much kind of bad press for causal powers and so many different views of them that had been done in the past and nobody would think about. I made up a new word, right? It was capacities. Capacities, unlike causal laws, by their very nature, okay, they give us levers on the world. If a cause has a stable capacity, it will play the same causal role in different circumstances. Remember last time I talked about causal rules because RCT's results only travel if the cause plays the same causal role in the new situation as it did in the old. So if a cause has a stable capacity, it will play the same causal role in different circumstances. So it can appear and in the same form in a great variety of different causal laws. Now, the concept of a causality or of a capacity characterizing capacities is twinned with that of a contribution. Okay. Capacities are identified by the contributions they make. They are matched one-to-one with their contributions. They are thus what metaphysicians, I think, nowadays call single-track causal powers. Okay. If X from our causal law, CP, has a stable capacity to contribute Bx to Y, then we can rely on X to contribute Bx to Y across a variety of different circumstances governed by different causal laws. So all the different causal laws will have Bx in them, right? But they could well have, or will have, right, different alphas and different W's. Some won't have any W's, some will have just totally different W's. But if X has a capacity to contribute this to Y, then this will appear in a huge variety of different causal laws. Okay. Gravity is a prime example. So masses of size m have a stable capacity to contribute a force of g mm over r squared to the total force on another mass, regardless of what other kinds of pulls and pushes the other mass is subject to. So no matter what other kinds of causal laws are true of the object, mass will always contribute, make a contribution of this size to the total force. The total force is the effect here, y. Now, knowledge of capacities and their contributions helps us to change the world. A capacity, when properly triggered and not interfered with, will produce its associated contribution. Except some are probabilistic, and that's an aside story, okay? So when a cause has a stable capacity, we can reliably predict what difference it will make, regardless of what else is going on. The relations between capacities and their contributions have a number of important features then. Okay? Invariance is built right in, not added on. Okay? Sorry. They are not fragile. They do not break easily under the manipulations we make on them. And it is in the nature of what a capacity is that it produces its contributions no matter what else is going on. Okay. We have good empirical reason to think that this is a category that applies in nature, and that the good empirical reason comes from all of our analytic sciences. So physics and economics all work on the analytic method. You find what a cause does in isolation, and you assume, you try to find that about those causes such that what they do in isolation is what they'll contribute elsewhere, so, like the force of gravity. Okay. So I think we have good empirical reason to think that capacity is a good category to use to describe the natural world, and moreover that capacities are common in nature. They're not universal, but they're common. Okay. We know that we can get reliable knowledge of them, though not by using just the methods for establishing causal laws. That was the point. Causal laws are something different. These have invariance built in. They're a totally different kind of beast that we study in different ways. Nice thing about them is we can make use of them. They provide the tools to build what I call nomological machines, which I'll talk about next time, which are structures that give rise to causal laws. So new machines give rise to new causal laws, and by identifying machines, we can tell when a causal law is stable. Okay. And that's what we'll do next time. Now, or, that's what I claim. But, can we make use of them? Recall how the scientific revolutionaries made fun of the Aristotelian powers of their predecessors. So here's a kind of conventional dialogue from a scientific revolutionary making fun of an Aristotelian scientist. What makes heavy bodies fall? Gravity. Oh, well, what's gravity then? That which makes heavy bodies fall. You can see this in the old documents. Okay, so the connections between capacities and their contributions are not enough to allow us to predict what happens under manipulations. To do that, we need to have some way of ascertaining when a capacity obtains and when it doesn't. You've got to have some way of telling a capacity is there other than just by sitting around waiting for its effect to happen. Otherwise, it's not any use to you. Okay? Now, so to make use of capacities, as I claim we can, we need to have some way of ascertaining when a capacity obtains and when it does not. But nature has been good to us. Okay? For many capacities, we do have just this kind of information. Hard won, but we have it. Mass, which we can independently identify as a feature, is associated with the capacity to attract massive objects. Negative charge with a capacity to attract positive charges and with a capacity to repel negative charges, etc., etc., etc. Physics is rife with these, and economics purports to be. I mean, if you could take seriously what they do, it would be rife with capacities too. Capacities can be useful to us just because, in many cases, nature supplies secure ways to recognize them. There are features that we have independent methods of identifying that guarantee the presence of the capacity. Okay, what is central for my purposes here about capacities are the two facts I've described. Okay. Capacities reliably produce their contributions when triggered, and for a vast number of capacities, we have learned how to tell when they are present and when not. They are associated in a systematic way that we know about with features we know how to identify independently. Together, these two facts guarantee that we can make reliable predictions about what differences will result when we manipulate the capacities. Now, that's the end of what I was going to say about capacities formally, but because we had this yesterday, I've added on a bit that will bring us full circle. Here we have Esther Duflo and Anujit Banerjee. They're big movers in the Jamil Poverty Action Lab, which is located really centered around the MIT economics department. They're hugely influential. There's good bet Esther Duflo is going to win a Nobel Prize in economics next time around. As I said, they're the good guys. They really care about development. They argue that we should be doing small projects because we can figure out what the effects of small projects will be, etc. They are very keen on RCTs. Okay. World Bank should not do any project, fund any project that's not had a successful RCT behind it, as if somehow that means it will work the next time. Okay, so I distinguish in looking at this literature and evidence-based policy between three kinds of causal claims. It works somewhere claims, general claims, and it will work here claims. RCTs establish it works somewhere claims. Okay. We want to know it will work here. And it sure looks as if the conduit is through, they think, is through general claims. I just kind of think it's a default that if it works somewhere, it works generally, so it will work here. Okay. So Let's just have a look here. Duflo and Cramer. Second paragraph of a paper. I wasn't cherry-picked. I just found this. Use of randomization in the evaluation of development effectiveness. That's the kind of paper, of course, I was wanted to read what they had to say. The benefits of knowing which programs work extend far beyond any program or agency, and credible impact evaluations can offer reliable guidance. Okay. Well, which programs work seems to me to mean it works in general. Impact evaluation, that's all about, we talked about that last time, that's it works somewhere. Reliable guidance is, it'll work here. And we flow seamlessly from one to another. This is what I meant by inference by pun. Okay? This is strategizing by pun. Okay. So think about laws versus capacities. It plays a causal role there, here, somewhere. Okay, that's a causal law claim. Okay. It plays a causal role widely is a claim about that there's a relatively stable capacity to produce the related contribution. I mean, they don't actually think you're going to get the same effects, but that every time you introduce this cause, it'll make the same difference. I mean, every situation, they admit, does have lots of other factors going on. So the W's will be very different, so there'll be different causal laws, but they think, every time you introduce it, it'll make the same difference. That's the hope, right? That's a capacity claim. Okay. So, but the problem is, right, that the causal laws that are established, they're fragile and local. We saw the case of Bangladesh versus Tamil Nadu. I mentioned Lucas, who says you can break causal laws easily. Okay. Now, RCTs establish causal laws, but for generality, you need capacities. Okay. So, conclusion, causal laws are fragile and local, and for generality, you need capacities. Thank you.
Thank you very much. First of all, I am as anti-human with respect to causality as you are. So whatever you think of my remarks, they have nothing to do with any effort to defend Hume here. Now, you've really been into both physics, economics, and medicine. But I'm a bit suspicious that you seem to me to treat them all alike. I have two comments to make. The first is that you wrote that all causal laws are situation dependent. As I have learned, they speak about causality in medicine and economics. I would say yes, but you seem to bring in physics as well, and then I can't follow you. If it could have been the case that Newtonian mechanics were true, then well, his laws are to me completely universal. The third one, action equals reaction, each and everywhere at every time. Second law, resultant force on a particle with mass m equals the resultant acceleration. And I can see that you must regard many universal laws in quantum mechanics as non-causal laws. But are you really prepared to say that Newtonian mechanics, not even that, if true, contain situation-independent laws? That's my first question.
I'm, in fact, prepared to say it, and I have said it, and that's part of what's the argument in the book called The Dappled World. But let's not, you don't have to be...
I know the book a little.
Yeah, well, so let me back up. In Newton's law, like the F equals ma, I think that I think I can defend that contrary to what many people claim, it is a causal law. It tells you that when a force is exerted on an object of mass m, that will cause it to have an acceleration a. And I think if you don't give it the causal reading, then you don't get the power out of it that's necessary to justify the uses to which we put it. So you can't actually build the machines we do with it if you don't take it as a causal law. So I'm like you, right, I have to take it as a causal law. And in that case, right, It might be. You know, you don't have to be as radical as I am. One could just say there are some, right, invariant causal laws. Most causal laws that we run into and use all the time are not invariant. And it's because they're not invariant that we have this problem. And I actually think most of the ones that aren't that I really understand and aren't invariant, I can explain the nomological machine that gives rise to them. I mean, I can explain, you know, what they depend on. Right? So if I went along with you that Newton's theory is really true, pretend it's really true, and also could it be universal? Absolutely, could be absolutely universal. I happen to think that none of them are, right? But okay. And then you could the situation relativization would be you would just write the word anywhere there. But I want to leave it in because I want to call all those other things causal laws where there's a more restricted domain. So, you know, I mean, it's just a trivial fact that if you say it's relativized to situations, you're entitled to sometimes let the situations be anything.
Okay.
So,
yeah. Okay. The second question, if I understand, has to do with now medicine and economics. Yesterday you talked about RCTs. And then you continue today, and mentioning them a little. But if I understood you right, all the people that you referred to were economists, and therefore, when you talk about causal criteria and so on. But in medicine, some people have put forward all similar list. Hill is the most famous, I think. I wouldn't regard them as neither necessary nor sufficient, but they are used and called criteria. So how can you be so sure that what economists say about the social sciences, also about the economy, is applicable with respect to the RCTs of medicine? I would...
Okay, well, yeah. About the RCTs, I can be confident because you can try to construct for yourself what. I mean, here's the job. Okay, so I've got two things I want to say. The first is let's think just about RCT. Here's the job. What does a causal law say such that RCTs could possibly be the gold standard for finding it out? Okay, and if you take causal laws to have the characteristics I ascribe to them, then RCTs are provably, in the ideal, and an ideal RCT is provably a good way to find out about causal laws in the sense I say. Okay. That's about RCTs. About other methods, it turns out that actually econometric methods are provably good for finding out about medical causal laws. Provably good. Now, what about Bradford Hill? Well, Bradford Hill gives a lot of criteria that he says are, I forgot what the words are, but you're not to take them as either necessary nor sufficient, but they're things you should look for. And if you've got a lot of them, you should assume if you don't have them, if you fail to have many of them, you should. But some of them are that the effect is big. Well, we know very well that can't be a necessary condition because there are causes that produce little effects. So Bradford Hill has a kind of set of conditions, and half of the conditions are, I don't know whether literally half, sorry, I'd have to go back to the list, but a large number of them are conditions that I can prove are either necessary or sufficient for causal laws and that look like CP. Okay. The other ones, I think, you can see why they'd be rough indicators in some circumstances. Like this thing about being big effects. It's not a sign that something's a causal law. The role it plays for him really is that if you do something like any kind of statistical method for finding out causes, okay, it's very, very difficult to, you have to have a huge population if your effect size is small. I mean, so if the cause only makes a small effect, then it's very, very much more likely that you'll get a small effect size by accident if you've got a small population. So some of the criteria that Bradford Hill states are, okay, some of them are reasonable, some of them are either necessary or sufficient for causal laws in my sense, some of them are things you could see why they, under the right conditions, would either be necessary or sufficient, if this particular case satisfies certain assumptions, and some of them, like the large effect, that the effect should be large, are ones that don't have anything to do with actually whether it's a causal law or not, but whether or not our conventional methods will, given the size of the populations we normally have, be good for finding it out. And Bradford Hill is very, it's very often cited now. And the evidence-based medicine people are going back to looking at Bradford Hill, because they're trying to loosen up a bit. And so it wasn't. The side conversation should be. It's about something that's really at the moment very important. I did all that technical stuff. There's got to be some objections to that. There has to be some objections to. I'm waiting for Bengt to say something back there.
Now, you mentioned determinism and deterministic laws, probabilistic laws, and okay for me, good, both are there. But then, in another way, you talked about, as is necessary, about manipulating factors and manipulating factors that affect laws when you talked about this Phillips curve. Now, for me, the word manipulation brings in something beside determinism, deterministic laws and probabilistic laws. And many philosophers think so, namely agency. And what's beneath me and my suspicion that can you really move as easily as you do between economics and medicine has to do with this fact that, well, if you take the body goes on, but economics is very much about agents. You see what I mean?
No, sorry.
In this way, simple way then, for me, we have some kind of free will. We are free agents, and therefore there is an aspect in the social sciences that is missing in the natural sciences and in part of medical science. I
agree with that, and that's why I think an awful lot of causal laws are, that fits naturally with thinking causal laws are situation relative. So there are certain kinds of not only social but physical causal laws that hold in the situation where I don't exercise my free will to come along and mess things up. So there's no problem there. What happens in the economics cases where these guys who are economists don't have agents with free will. They have agents who are absolutely determined by whatever it is to act rationally and greedily, and that's how Lucas gets his models to work. He's got a rational expectations theory, and the agents aren't. They're just doing willy-nilly. They've got a set of given preferences, right? And they just do what it takes to maximize their expected preferences in the face of their expectations about the exogenous shocks in the technology. Now, that's one reason why I think probably economics, I don't believe in rational choice theory or rational expectations. I'm very wary of, sometimes the models are right, but like you, I'd want to, before I bet much on them, I'd want to really look at the model, see the situation, and so forth.
Okay, so this is completely confused. I don't even know if it's a question, but could we go back to where you talk about these capacities?
Yeah, that's why I got the. It's so small.
Yeah, I think you should just continue. This one and then down one, I think. I guess.
Is that one okay? At least I'm
yeah,
close, I'm
yeah, I
close
think so.
enough
I
there.
think this one is okay. Yeah, it's coming. So, I mean, I just want to know more about these capacities because I'm not really sure I understand the difference between these causes in the causal laws and then the capacities. So when I was sitting here, perhaps this is completely wrong, I was thinking that in the causal laws we are on a different level of description, you might say. So it's like some of us metaphysicians would say that when you go to the capacities, you go to the truth makers for the or something like that. But could you say something more, first of all, about that relationship between the causal laws and the capacities? Because maybe it's just me, but I wasn't.
No, I think when you're if we're thinking in the formal mode, that it's just a different level of modality. That ascribing a capacity is very different kind of modal form than whatever it is to be a causal law, right? And that you might you can write causal laws out. I mean, let's just take a causal law, and then C can contribute, the cause can contribute something in this situation that you could never expect it to contribute in another situation. Mothers contribute to the education of mothers contributes to in Bangladesh, in Tamil Nadu, to the infant's nutrition, but educating the mothers does not contribute, produce the right contribution in Bangladesh. So it's not the case that every time a cause is part of the overall story about why the effect is the size it is in one case, that's because that cause, you can take what it's doing there and think, oh, it'll do that everywhere. That's a very special case that it'll do that everywhere. And that's the thing for which the label causal power is reserved, or I reserve.
For that which happens in a particular situation?
No, that when what happens in one, this is not a definition, it follows from the notion of a capacity, that what it contributes in one situation, it will contribute in all of them, or all across a range. That's just not true of causes in general. So
it's just like a subset of the causes, and then you call those causal powers because they are invariable?
Well, I don't think that causal powers are a subset of causes, but that's partly, depends on one's ontology.
Yes, I think my question is a question on ontology, actually, because...
Well, a property, I mean, here's an ontology one you could have. You could have properties, and properties the obtaining of a property can be a cause. Okay. So the obtaining of educating the mother, in this case, was part of one of the causes that produced the child's nutrition. Okay. So that's a feature in the world. It's a feature in the world, and it's when it occurs in this situation, it does cause something else. So it is then appropriately labeled a cause, or it is a cause. Okay. Now, I would say that it brings with it, or not, a causal power. So but some people think that properties are, you can't think that properties are, I would say it brings with it a causal power.
So a causal power is not the same as the instantiation of a property then?
No. Causal power...
It's a separate category?
It's a separate category.
That comes along with instantiations of properties?
Yeah, so one of the things, and it might be, so this is a dispute that metaphysicians worry about, is if you've got two categories, you've got kind of inert properties, whatever those were, but whatever it was that Hume was supposed to have and that David Lewis believes in, and John Ehrman and those guys, that you've just got these inert quantities, qualities, factors, you've got these inert ones and they don't have any causal powers. Well, I think that there's another category, there are causal powers, and that in the cases I know about in science, where you want predictability, right, we talk about the causal powers when we can independently identify a property that they're always associated with.
So, I mean, so then I have a question, then I'm going to...
Can I just finish
yeah,
that?
sorry.
Yeah, okay. So, I don't have a doctrine about whether their, causal powers need always to come with properties. Right? Some people think that they're, they have to, and then they try to ground them in them, and I think that I think is a mistake, and I can argue against that. But whether or not you always need I just think we don't know. That's an empirical question for me. What I do know is that there are some things what I do believe is there's some things I know, like having the property of being negatively charged always has with it the power to attract, the capacity to attract positive charges. Having the property of being a mass has the property, gravitational mass has the property of attracting other gravitational masses. Okay, so that, yes, now you want to ask.
Yeah, so then just a small question, because if you go to the literature in metaphysics, because it sounds to me like you have causal laws that are not, necessarily successful, so to speak. They can fail. But once you have the power, there is this reliability, as you say. So it will perform. If you have identified a causal power, then you go somewhere else and you find that causal power again. You know what it will do if you poke it,
Yes.
It will do it. So there's a kind of success story behind the causal power that's not the case for the causal laws. But this doesn't really square well with some of the things that metaphysicians say about causal powers, because they seem to think, the causal power theorists seem to think that causal powers are precisely the sort of things that have the capacity to do X, but necessarily they don't have to do that. They can be... So that they are not, in this sense, these success machines.
And I think that they're mistaken. Well, I think there is something we have good reason to use this category, and that the masses always attract. Okay. So there are two remarks. Right? One is that one of the reasons I call the capacity view a causal power view is because I think Hume wouldn't like it. Because Hume said it doesn't make any sense to make a distinction between the presence of a power and its exercise. Okay? So he thinks there's the presence of the cause and then there's the presence of the effect. But I've got three things. The presence of the feature that brings, the presence of the capacity, the presence of the power, the occurrence of its contribution, and the observable effect, the effect in the set of features that Hume would admit. So, when the object is accelerating downwards, when the Earth is pulling it downwards, the contribution of the Earth to its downward acceleration is there. The contribution of the magnet is there, and the bloody thing isn't moving. Okay. Now, you can try to save Hume by saying, yes, it's moving up, but it's moving down. But there are more complicated examples with circuits and things where which you can only make sense of, I think, if you say, look, there's the power, there's the contribution, and then there's what I call manifest result. But usually powers people get confused between whether the manifest result is what I call the contribution or the observable or the Humean, the feature which occurs in David Lewis's world. Right. So, sorry, now why did I say all that? It was to explain why I think it's one way in which it's a causal powers view, is that it lets in things that I think if you're Humean you really ought not to have in the world, because they're and moreover, okay, another feature is that if you do it the way I do it, which I do in order to make sense of our powerful results in science, if you do it the way I do it, then I identify the power with its contribution. So there's an analytic connection between them. That doesn't mean that it always produces its good, but the power it is defined by, back and forth by its contribution. It isn't gravity unless it makes heavy bodies fall. So I do exactly what the scholastics say. Now that doesn't mean that it would have to be the fact that gravity, if gravity has to be the kind of thing that whose contribution is making heavy bodies fall, it doesn't mean that it always has to, the fact that there's an analytic connection definitionally between what the power and what the contribution is doesn't mean that it always has to make that contribution. But in fact, I think we have cases in science where it does. But then I don't know if you noticed, but at some point I said I hedge for Finkish dispositions and all that a power, if properly triggered and not interfered with, will. And I think many things like mass don't need triggering. They're hard to interfere with. I don't actually think that most of the cases are really interfered.
I think I was confused by the fact that it produces contributions despite what else goes on.
The what else is going on is that gravity is making its contribution even if a magnet's pulling it up. But it won't, if you genuinely think it could be interfered with, it won't do it if it's interfered with. So the formula is capacities, when properly triggered, produce and not interfered with, where you can imagine that because I believe in capacities, I believe that it's not, there's a real fact of the matter about whether it's been interfered with or not. It's not, it does it unless it doesn't. Right? It's that being interfered with is a proper happening.
Things are much clearer to me now, so thank you.
Well, thank you, because hopefully that made them clearer to other people. Sorry, having challenged Bengt but I didn't think you were going to let me get away with all this stuff, Bengt.
Well, you stress the connection between metaphysics and methodology. And yet, I think you haven't really touched the very heart of the metaphysical question, which for me is the real causal connection in the individual case. I'm not so much worried about causal laws or causal powers, which could be construed as sort of general lumping together of the real tricky stuff, namely what in an individual case distinguishes a genuine causal connection from mere co-occurrence. And I would like, if you would like to go back, I presume you're familiar with German Hessel's example about argument against the probability theory, about contraceptive pills.
Yes.
That may cause blood clots. However, on the statistical account, if women take contraceptive pills, the probability goes down because it screens out pregnancy, which is a much more efficient cause. Yet, in those cases where there nevertheless are blood clots, it seems indisputable that they are caused by the contraceptive pills. Yeah. And that has to do with what is functioning in that individual case. And if we can come to grips with that, we will, besides solving a metaphysically interesting question, we may just look at causal laws as sufficiently general clustering of the occurrence of such things. So that seems to me be the very heart of the matter that really frustrates me, that I don't understand.
Okay, so let me say several things. I want to talk about singular causings because I think that's the interesting issue, but about Heslow's birth control pill cases, this is a kind of typical thing, and just to connect it with a standard literature now. So the probabilistic theory of causality, and as Suppi's did it, and Bayes-Nett's theories both assume that if there's a relation, a causal relation, the cause increases the probability of its effect. Bengt has just given an example where the probability doesn't go up because the cause both has a route by which it would, if this one weren't occurring, it would increase the probability, but it has another route by which, if this one weren't occurring, right, it would decrease the probability, and the two balance out. The guys who do Bayes-Netz's method say, that doesn't happen, or it has a set, it happens, then they've got some, artificial, sorry, I'm being rude. They have a mathematical argument that says it's a set of measure 0. That doesn't happen. I think it happens all the time. Kevin Hoover, I think we do it, you deliberately make it happen when, when one of these causal pathways is deleterious, then you try to do anything you can to enhance so that shows that I think Bayes-Netz's, I wouldn't want to turn a Bayes-Netz's, as I've tried to, I wouldn't want to turn a Bayes-Netz's I wouldn't want to turn the Bayes-Netz's axioms into one of those characterizing features of causality. I think they only hold in very special systems. So that's the first thing. Second, when I endorse probabilistic theory of causality and say I can prove that it fits with my reading, and my reading's got singular causings in it, so it looks like it's wrong because some of these women are caused to have thrombosis, right? And some of them are prevented from having thrombosis. The singular causings are going on, and it's not reflected in the increase in probability. If you actually look at my formulation of probabilistic theory of causality, it essentially says, look here, when you can infer the causation from an increase in probability is when all the other sources of changes in probability have been controlled for. Not just all the other causes, but all the other... now, in this case, we know how we can control for it. You can hold fixed something on this wing, and then this one will show up. You can hold fixed something on this wing, and that one will show up. How you might have noticed I said that at one point the way to formulate the probabilistic theory in this situation, and it will differ from domain to domain, what's the right way to formulate it. So okay, so what I put there, right, is not the right way to formulate a probabilistic theory of causality if you want my representation theorem to hold. It's the right way in certain systems in which you can prove the representation theorem. Okay. Then lastly, the interesting question is the metaphysics of these singular causings, and I don't have any metaphysics for them. And now I'd like to suggest that I don't need one. That the world is full of happenings like the cat slapping up the milk and my pushing the glass over, etc., that are, well, maybe I need a metaphysics for them. They're there in the world. It's not a problem that one has to say, how to get this causal relation in out of other things. These causings are going on all the time. Now, why are some things that happen causings and some things that happen not causings? That I don't really have a view about. And I think that we have, there are pushings and pullings and shovings, and then there's beings to the left of, and the first ones are causal and the other ones aren't. And the pushings, pullings, shovings, droppings, etc., all have a family resemblance, right? They involve any of those things Anscombe says. Is the Anscombe? Where's our Anscombe person? She left. I was going to get her to defend it. That there are a number of rough criteria, right? But I mean, then we're on ground. I don't have a strong. I don't have a seriously defensible claim, but there are a lot of criteria. The effect comes out of the cause. There's a continuous process. There's the first makes the second happen, or is in some sense responsible for it, etc. And if you've got something on the metaphysics of singular causings, that would be great for me.
Because sometimes, for example, courts of law have to decide on what's the cause in a singular case. And I would like to have philosophy to have something to say when that's justified or not.
Yes.
So,
and the problem is I wouldn't want to have to say that the thing that David Lewis says is that every time there's a singular causing, there has to be a causal law. I mean, there has to be a feature you can not you can identify, but a feature, an identifiable feature in the cause, the start of the sequence, and an identifiable feature in the end, such that those two features are always connected by causal law. I wouldn't want to be committed to that. So, which is part of the point of taking singular causings first. So I've got a real problem with the law cases, but I do think we have Mark method, right? And then we do have causal laws. We can call it local causal laws that hold in this situation. You can call into play. We do have Mark method, and we do have it needs a cause and nothing else. In the mystery story, I don't think you were here when I talked about mystery stories, but where Ackerley was the cause of, or wasn't the cause, I forgot, of because, but the idea was that he was because all the other possibilities had been ruled out, and there was a spatiotemporal route, and the kind of things that allow this kind of person to be the cause were their mode of opportunity, etc. I guess that means we have a lot of subject-specific knowledge about causes. People tend not to murder other people unless they have the opportunity. They tend not to murder people unless they have motive. They sometimes do, etc. Yeah.
I don't.
We can't go upstairs anyway till dinner's ready.
Yeah, that's right. So I'm just gonna, isn't causal powers among people like George Molnar and those guys, aren't they introduced precisely to deal with these kind of singular causal relations? So that the idea is that, the underlying metaphysics is exactly these particular powers. So if you can, from the epistemological point of view, if you're in a court of law and you can prove that there is this happening and there was this manifestation, and when you look at the happening, you can actually see that there was this power and that there were no interfering factors and blah, 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 then this would actually be, very good reason to think that this is a causal relation and not a non-causal relation. Whereas if there is the power, but there are interfering factors, or there is no causal power, no particular power in this case, but there is the happening and what you could call the manifestation, then there is no such reason. So,
I was with you until then.
Okay.
Okay, those are all reasons.
Yeah.
But the idea that there's no such reason because there can be local causal laws, right? And local causal laws can be like educating the mother.
Yeah.
Is in Tamil Nadu,
yes,
right, is a partial cause of the nutrition level of the child.
So you think that there can be causal law, true causal law without any powers?
Yeah.
Aha.
Well,
that's interesting.
No, what I think is that there can be true causal laws where the cause, right, doesn't have the power to contribute what it does in that case. Now, the reason I said no is because I've got this more complicated doctrine that I was being made fun of here, quite rightly, that most causal laws are ceteris paribus laws, and they depend on an underlying structure that gives rise to them, this thing I call a nomological machine, that I'm going to talk about next time, so that, and then I think nomological machines function by powers making their contributions in certain arrangements. So the powers have to come in at a lower level in order to get most causal laws. But then when you've got the causal law, I don't think there's any doubt that educating the mother can play that causal role in that setting, and that can be a reason to think that educating the mother in this case did do it. I mean, this kid's nutrition went up, we educated the mother. Of course, that could be an accident because it's not 100% causal connection, but we have good reason to think that it was causal between the two, because there is actually a causal law, and it's causal in lots of cases in Tamil Nadu. On the other hand, if you do think that there are ungrounded causal laws, not grounded in nomological machines, then to the extent I buy that, then you can have causal laws without causal powers. So there really are, for me, two. I don't just mean for me. I mean, I would like to claim that I don't just say it, but that the whole picture makes sense together as a way of making sense of science. And of course, I come at it not from the way of trying to make sense of the singular causings, but trying to make sense of the science. And so I start with the singular causings and build up the powers, right? I also don't like the fact that they think that causal powers have to have grounds. I mean, the guys who want to have grounds for them, like Bird, Alexander Bird has that's what Rom Hore had. That's one reason I didn't talk about causal powers, because I didn't really want to be mean to, I didn't want to disagree with Rom, because he was the good guy. He was talking about causality. Right, but I didn't think they had to have a ground. I thought that wasn't radical enough, that causal powers, they're not grounded in a causal, a factor that's then connected with causal law, with the contribution.
Like Monarch, these are ungrounded.
Yes, his are ungrounded, and lots of them are ungrounded. Lots of them, yes, and they're identified by their causal profile. Which I think is a mistake. That's a story. You and I can do some metaphysics.
I agree.
Yeah.
Okay. Thank you very much again.
Thank you all for the discussion, which is why I came.